let's talk about how you can find the degree of a polynomial when it's in factored form. Okay, remember degrees are important because they let you know the general shape of a polynomial. If you have a degree that's odd, for example, these three, the degree of 1, degree of 3, and a degree of 5, then you know that the end behaviors are different. One ends down, the other ends up. One ends down, the other ends up. Okay, if you have a degree that is even, right, like a quadratic or a quartic, then you know that either both ends are up or both ends are down, depending on the sign of the leading coefficient. So knowing the value of the degree lets you know what kind of end behavior you're dealing with. For example, in this function a of x, I know that the degree is the same as the highest exponent, which is 5, so my degree is 5. My leading coefficient is positive 4. So I know that this polynomial, because it's odd, is going to have its ends pointing in two different directions. And because the leading coefficient is positive, then it's going to go up from left to right. So it's going to start low and go high. Okay. For b of x, because this polynomial is in standard form, I know that its degree is 7. It's just the highest exponent. And the leading coefficient in this case is negative, -2. So its ends are going to be going in different directions because the degree is odd, but because the leading coefficient is negative, it's going to start high and go low. So it's kind of sloping negative as you go from left to right. Okay, so from the degree and the leading coefficient, you can get a general idea of what the ends of these polynomials are supposed to be doing. If the function is in factored form, it is not quite as easy to tell the degree. You can't just look at it and say that the highest exponent is 2, therefore the degree is 2, because that's not true. All right, so let's get rid of that idea. If I'm in factored form here, if I have x minus 2 squared, remember that that's the same as x minus 2 times x minus 2. And then I still have x plus 1. If I wanted to put this in standard form, I'd have to multiply all this out. I'd have to distribute it. When I do that, I get something like x squared minus 4x plus 4 times x plus 1. And then if I were to multiply this binomial with this trinomial, can you convince yourself that the highest term would be x cubed? That would be the first term. And then the rest of this, I'd have to figure it out. Plus x squared minus 4x squared minus 4x plus 4x plus 4. And then you'd combine your like terms. But once you multiplied everything out, you realize that the degree of this polynomial, the highest exponent, is 3. And that comes from the fact that there's two x's here, x squared, and then another x. So you're going to take an x squared times x, and that's going to get you a degree of 3. So what you're doing is you're sort of adding up all the x's that you see in these factors. All right, so for example, if I'm looking at this, I see that there are 5 x's here, and if I were to multiply this whole thing out, which I don't want to because it would be a pain, if I were to multiply this whole thing out, my first term of that would be 4 x's. So I would have an x to the 5th times an x to the 4th. So the highest exponent I would have is x to the 9th. This is a degree of 9. So you are trying to account for all the x's that you see, realizing that they're all going to be multiplied together at some point. All right, in standard form, your degree is just the highest exponent. In factored form, however, you have to add all the exponents because they have not yet been multiplied together. So when you are looking for the degree of a polynomial, you have to ask yourself, is this in standard form? Is it an easy way to find out, or is it in factored form? Do I have to add everything together first?